I'm Eric Schlappi from Schlappi Engineering. I've been asked to talk about distortion. For people familiar with me and my work, this may not come as a complete surprise. I don't know where I'm going with this. I'm going to start the talk. So there's a bunch of different distortions of definitions. There's a bunch of definitions of distortion. The most general definition is the hi-fi one, which is just anything that affects a signal. You put it into a system, some sine wave with one harmonic, it comes out of the system. Any of those harmonics are distortion. And often, when you're talking about this sort of system, the distortions you're looking for the most are how different signals affect each other, intermodulation. Probably what we think about a lot when we're talking about distortion is guitar distortion, which is a saturation or clipping. Anytime you take some rounded signal and push it into a system and it comes out a little more square, this is generally, that's saturation. If you just straight up cut off the top, that's clipping. We're not here because we're playing guitars, we're here because of synthesizers. So in the synthesizer world, distortion can be pretty much anything. Simple clipping, like guitar world distortion or saturation, is not super interesting in synthesizer world because we already have square waves, for sure. Also, what makes the simple saturation in guitar world so interesting is that you have complex waveforms and you have like a direct physical control over the dynamics when you're pushing it into this saturation, this nonlinearity. We have lots of controllers in synthesizer world, but we don't have generally the same sort of physical relationship with dynamics. We can create them with VCAs, but we still want more dramatic effects usually. We are used to a bunch of pretty standard ones that I'm going to put in this definition. Wave folders, I would call distortion. Wave shaping, just inside your oscillator, a lot of them have triangle cores. Turning it into a sine wave is actually, I would put that as a very highly tuned form of distortion. Rectification, cutting off the bottom of the waveform or flipping it up. I would even call resonant filters a form of distortion, which comes to our next definition. It occurs to me that I should make sure I have a timepiece around before I get too deep into this. I think the definition that most of us are actually thinking about is the aesthetic definition. It's something that's organic, raw, abrasive, tied to musical genres, heavy metal, noise, dubstep, extreme stuff maybe, or just, not clean. And we can get there with lots of types of synthesis without a processing step. We'll get to that in a minute. So I kind of wanted to start simple and then go from there. So, see if we can clean it up. We have, let's amplify this a little bit. So I'm running a triangle wave, just a nice clean triangle wave from the 3-body into the input of the 100 grit and taking it out as a nice clean triangle wave, or cleanish. It probably isn't all that clean. The input stage of the 100 grit is actually a classic, just simple transistor-based stage with the gain set that we can saturate it pretty easily. So this is an example of your guitar-like saturation, or even not too far from a simple triangle to sine converter if you just push it a little bit. And you won't hear that difference much because there isn't really a big difference between triangle and sine waves. But if you keep pushing it, you'll get to a square wave. Something worth talking about with square waves and saturation type stuff is that you're generating harmonics. And generally speaking, if you generate these harmonics symmetrically, both with your process and with your original waveform, you generate odd harmonics. And asymmetry will give you even harmonics. Which one you want is maybe not all that important, really. Like, the guitar forums will try to put aesthetic meaning to the harmonics, saying these ones are good and these ones are bad. But I don't think we really hear like that usually. Any tone, constant tone, your ear just gets used to. What's important is usually movement and not any set, like, there's no right waveform, right harmonics or whatever. But you can, you can add, say, like a low frequency waveform to this, and you'll get some form of PWM just by pushing it into the saturation point. And that will generate this movement of odd and even harmonics that's pretty classically useful in the synthesizer sense. You can also clip the waveform. The 100 grit that's the clean output. The distortion output has a so its second output has a distortion chip, an amplifier. Let's see, I think I'm planning to talk about that more in a sec. Oh yeah, so this is a waveform, or a graph that I took from the Electric Druid website that I really like. I think this guy's name is Tom Whitwell, and maybe he's in this vicinity. But he has a bunch of really, really nice graphs showing how different waveforms create different harmonics. In this one, it's showing how your first harmonic, your fundamental, the actual note you think you're playing, is pretty dominant when you have the duty cycle at 50%, and then after that you get the third harmonic, the fifth, the seventh, and so on. And then as you change the duty cycle, the best way to think about it, I think, is taking energy from the fundamental and moving it into higher harmonics. So yeah, the next step to make saturation more interesting is feeding it back in some way. The 100 grit has all sorts of feedback paths built into it, but I kind of wanted to patch this independently so that you could kind of get this, so that you can apply it elsewhere. So I'm going to patch it through this module that I may or may not ever release. That's a prototype. And the one I showed the previous version of this, which I will almost certainly never release. So I don't know. Don't ask me about this too much. So what I'm doing is I'm taking the output and running it through a, let's see, I think this one is the rectifier. Yeah, so this is actually a comparator, and this is similar to the way the angle grinder works. Just shoving something that goes high or low depending on whether the signal is above or below 0 actually in a feedback path often works quite nicely. Why is this so? Did I grab the wrong one? See what that looks like actually. Okay, yeah. So here's feeding back a rectified version into it. I guess we could just listen to the rectified output. Rectification is not the most interesting. Can't really see that on our scope here. But rectification tends not to be super interesting as far as what's that? Rectification tends not to be super interesting directly listening to it. It's usually nicer in a feedback path. And I was going to patch that, but maybe my prototype isn't working. So I guess you can just listen to what am I trying to do? What's the best way to do that? So I'm just going to go past that and say rectification sounds like a boring form of clipping. And clipping is a more exciting form of clipping. and that pretty much any filter that you think sounds good has some form of clipping or nonlinearity in the feedback path. I would actually say, because there's all this discourse about how filters are made in the synthesizer community, I'd say 90% of it is total bullshit. Basically, all that matters in a filter is how many poles it is and what sort of nonlinearity you put in the feedback path to shape the resonance. The rest of it is mostly a distraction. Not entirely, of course, because if you put a nonlinearity before or after the filter, that makes a difference, but you can abstract that from the filter itself, I would say. It's this feedback path that's interesting. In the case of the 100 grit, during the design of it, I actually had the synthesizer I liked a lot called the Realistic MG1. It's known as the Radio Shack Moog. I believe that Paul Schreiber of Synthesis Technology was involved with it in somehow. But simple Moog synth. And the one I had was modified with a input to the filter. And what I really liked to do with it was feed the headphone output, just because it was a spare output, into the filter input. And it made this particular screaming resonance sound. And when I was designing the 100 grit, I first put basically this filter and this VCA on the breadboard, and it just sounded like a Moog filter. And when you ran the output back into the input, it just sounded like Moog resonance, kind of a clean whistling sound. And it wasn't the sound I was looking for. Turns out what was really happening that made it so interesting was the resonance, or the feedback, was going through the headphone amplifier, which was clipping super hard. And the particular headphone amplifier used, I think it's called the LM386, is pretty famously used in distortion pedals and small guitar amplifiers. And that, let's see, where did our audio go? So if we turn off our input, this is just that feedback path through that amplifier. And if we bring in our input a bit and we kind of balance it against that feedback path, we get let me automate that a little bit. So that's more or less the sound that I liked from this vintage Moog, which is it's this balancing of these, this distorted headphone amplifier with the original input in the feedback path. And, this isn't the order I was going to do this in, but one nice thing when you're playing with feedback and trying to create these sort of distorted sounds, feedback isn't just for the audio path. You should plug it into virtually anything. You should plug it back into the cutoff. You should plug it into the resonance. A particular sound that I enjoy. Let's see, where'd it go? So we've removed our resonance. So here's sort of not quite the classic Moog resonance, but a nicely compensated. Let's go back to the non-distorted output, actually. A nicely compensated feedback path where you've kind of balanced the input with the output resonance to maintain some amount of the bass frequencies. Now here's a resonant path where you've taken the output through one of these distorted chips and ran it back into the resonance input. And you get something quite a bit you get some somewhat difficult to predict things happening in there. And then say run it through distortion again. And you can get things can get a bit extreme. So I wanted to talk about no input mixing because it has a lot of this same stuff involved. Like people like to track down very specific vintage mixers thinking there's something special about them. But you can do really nice no input mixing with pretty much anything. For those unfamiliar, is you're taking a mixer output and running it back into the input and turning it up. So you're just creating feedback. And then usually you're able to play this feedback with some EQs, basically the filters on the input of the mixer. One thing, so I was somewhat recently, don't ask me too much about this because this is another prototype that I may or may not ever make, but I was trying to build this into a little mixer that I designed. And something that I found about that was that nothing interesting happened until it started to clip. Like these interesting resonance paths require some sort of nonlinearity. That's how the DSP guys would talk about it. But some sharp, like you don't want just like a smooth There has to be something in there where it is difficult to model digitally, actually. But something like a diode or a transistor or just a sharp cut that creates these harmonics and feeds the feedback system. I think I'm patching a kick drum because that's something I enjoy doing into this mixer. Let's see if I can patch it quickly. And let's trigger it here. Off. So now we've patched a somewhat basic kick drum through this little mixer, and I've put a bit of a distortion on the output, and then I've patched after the actual mixer, I've placed another similar distortion as it's in the 100 grit, though I spend a little bit more time trying to make the distortion symmetric, because I was finding when I was playing with compressions and distortions that I do tend to prefer these ones that accentuate the odd harmonics, but it is nice being able to push them into an area where all the harmonics come out. In this case, we go through the distortion, then we go through bandpass filters and run it back into the input. And we get something that if you turn off any input, you're just getting feedback, droning tones. But if you let it interact with another source, some sort of interesting organic interaction happens. And something that's important to note about this, I'm not going to attempt this right now, but like this Mackie 802 in front of us, if you patch that output back into that input, you would have trouble getting this kind of like depth of tones that you could manipulate with it, because the more modern designs usually they just don't give you much space to work with where you're saturating before it's hard clipping. But you absolutely can get really nice feedback with it by putting some other saturation in the feedback path. So, of course, distortion pedals, but for a long time I was using this module by DPW. I'm not sure if Dan is in the audience tonight, but he makes this module called The Limit that's a really nice soft saturation. That's a really, any mixer that you hate, put that in the feedback path and it's going to sound awesome. Yeah. So, how am I doing for time? Something that I don't think gets talked about a whole lot, but any mixer that you hate, put that in the feedback path and it's going to sound awesome. Yeah. So, something that I don't think gets talked about a whole lot, but any mixer that you hate, put that in the feedback path and it's going to sound awesome. in a digital world, we're used to talking about wavetables and phase. So like a wavetable in a digital synthesizer, you output a sawtooth wave and it scans through a sample. And then if you disrupt that sawtooth in some way, you can get into like granular stuff for just phase modulation. Maybe not the most rigorous scientifically, but I think one interesting way to think about distortion and any sort of synthesis wave shaping technique like this is thinking about your output, your distortion, as being a wavetable, and any sort of other, especially low frequency content that you put into the input with the signal you're trying to distort as being a form of phase modulation. This can be really explicit if you're using wave folders. I have a wave folder here that I'm going to release in the near future. This one will get released. And this one, if you want to hear more about it, come to my booth, talk to me about it. It's a 4-bit ADC, but it turns out binary encoding maps really well into the same sort of function as a wave folder because of its power of 2 relationships. But with a bit of extra analog manipulation, I created this sort of sawtooth wave folder. Something that's pretty cool is to mix something else with the input. Whenever you're doing something like this, here's our wave folded content by itself. And then we mix in a low frequency oscillator, and we get something that has sort of a PWM-like quality. But PWM can also be thought of as a special form of phase modulation. And then if you take that second waveform and make it a ratio and animate it, could get to some interesting places. I guess what I'm really trying to say with this example is that whenever you're pushing something through a nonlinearity, think about adding something else to the input, especially low frequency content. Otherwise, think in the same way as you would about phase modulation and use something ratio related, and you'll get these products of the two waveforms. And then the last thing I wanted to talk about, so phase modulation is not traditionally what we would call distortion. But kind of using our aesthetic definition, we can get to places that sound like distortion to us. So here's a nice clean sine wave from the 3-body. And here's some nice clean phase modulation, just feeding down from the ratios. And while this does create additional harmonics, it's not something we would think of as distortion. You could get something that we think of a bit more as distorted by setting the second oscillator to be free and finding something that you kind of like the sound of that's inharmonic, and maybe just using a little bit of it. Or maybe it just sounds like phase modulation. But if you then feed the first oscillator back into the modulating oscillator, in this case with more phase modulation, definitely get to something that sounds like distortion. You can even do this with a low frequency oscillator. Back to the ratio-based example with feedback. Modulating it is always key. I think that's all I was really trying to get into, which gives us 15 minutes or so for questions and answers if this interests the people in the room. Ask me a question. So there was something else I forgot to mention, but this is a this one's pretty obvious. But so you can think of distortion as a way of moving energy from your fundamental to higher harmonics, mixing back in the fundamental is a good idea. Whenever people talk about distortion and they're like, oh, I want a distortion that keeps the bass, and they're like, oh, I found a distortion that keeps the bass, what that distortion is doing is mixing back in the fundamental, which is something you can do yourself. When you're doing this, though, there's probably going to be some sort of phase difference. So when you mix back in the fundamental, making sure you have some way to flip the phase, or filtering the two separately to eliminating the parts of the signals that are out of phase will give you a bigger sound. Any other questions? There was actually a really good, so I mentioned about the Electric Druid website. He's got some pretty interesting things where he just takes two identical waveforms and moves them out of phase and shows the harmonics that creates. That's another valid form of wave shaping or wave folding. It does something similar to these other saturation techniques where, of course, if the two waves are fully out of phase, then it'll cancel it out completely. But if they're just slightly out of phase, you can generate really high harmonics in this way. So something that the three-body does with its phase modulation is it creates this big stereo sound. If you the way this sound is created, because I have these phase-related outputs, the sine and cosine, and also the saw and cosaw. And I did something unusual here is where I actually created two different phase adders for the oscillator. For those unfamiliar, there's like an oscillator core usually, and then there's a shaper, and this is valid in both digital and analog oscillators. Anything added to the core oscillator before the shaper is phase modulation. So I created two different phase adders and took the same phase modulation but flipped the direction it goes for one of the phase outputs, which creates this. It means the two outputs go totally out of phase with each other. If they go a little bit out of phase with each other, you're going to run into phase cancellation issues, and it won't work well in a stereo field because it will cancel out. But if it goes really out of phase with each other, then it creates some sort of complex stereo field, and you don't really have to worry about cancellations in this way. I may have wandered from your, but yeah, phase is a bit different to predict, especially depending on these, what type of distortion you're talking about. So, again, Dan from DPW, I think, put the time and effort into creating a distortion module that does keep the phase lined up. This is something I usually don't worry about and just kind of trim to taste. But it's good, having multi-band filters is nice for this sort of thing, so you can take the part of each sound that you're interested in and mix them back together so that the phase at a particular frequency that you're interested in won't cancel out. You want some sort of feedback path. That's pretty much always, and then you kind of, so like with this no input mixing or whatever, the kick into some sort of feedback system, you need them. So I keep mentioning the phrase nonlinearities, and I don't know how mathematical everyone goes here, but like you need what makes all this stuff interesting, the feedback and the distortion, is pushing these signals into this function that kind of like changes the dynamic relationships. Like a compressor would be a good way to do this. But you need this push and pull, and it can't go into something that doesn't do this. Like you need some sort of nonlinear, like dynamic shaping function. Traditionally, this works better in the analog world. Modeling this stuff in digital is super complicated. So, in doing it in the digital realm, try messing with the sample rate. I know some like Reaper these days lets you change on. No, for your processing chain, like Reaper lets you oversample individual processing chains these days. I haven't used Ableton in like 20 years, so I can't speak to that. But the one difficulty with this stuff in the digital world is any nonlinearity technically creates infinite harmonics. That's why with my 3-body, I have the sample rate set at 12 megahertz, which is higher than 44 kilohertz by 256 times, because infinity is infinite. And dealing with this in the digital realm, there's lots of really complicated techniques to try to deal with this. But usually they have trouble dealing with this, the infinite frequencies generated by nonlinearities, and they try to get rid of them in various ways. I am the wrong person to ask for that. We have time for. I mean, so you need some sort of filter. This can be in a queue. You need some sort of mixing. And it's some sort of dynamic sound source. So like, I'm making a kick drum here with an angle grinder and a boundary. But like, hopefully, like some of these, like the phase modulation stuff might be a bit esoteric. But this stuff should all apply in any system. Like, so a microphone, a PA system, jam the microphone into the speaker, and you're doing roughly the same stuff. So a microphone in the speaker? The modular is nice because, like the way I'm trying to design it, and there are many others trying to do this too, trying to find the, if you can get down to the individual building blocks, you can do things like choose just a rectifier to put in a simple feedback path. One of the things that's hard about modular stuff is people want something that's small, so you make something with a lot of functions in it, and you can't get at these building blocks. But like a Doepfer system, like you can actually understand what you're getting at, maybe more than some of this or some of these other things. Or you can scream through a distortion pedal. We have time for one more. So the question was about sending feedback into different parts of the signal chain, not just the audio input, but you can send it into like the cutoff frequency of a filter, the resonance of a filter. Doing this into a VCA is nice as well. You're creating amplitude modulation. I would say just try it. And if it's not cool, flip the phase. Like find some way, always have some sort of utility where you can invert your signal. Because if the feedback is positive or negative, obviously makes a difference. And sometimes if you're going into like a cutoff or resonance, the signal's going to be unipolar, and it might clip your bipolar signal. So either offsetting it in some way or adding, I was talking about rectification can be useful. But you do, with any of these feedback paths, you do want to avoid DC offsets if possible. So another thing that can be useful is having a high-pass filter or AC coupling, because any DC offset tends to eat up your feedback headroom with something you can't really hear. Designing any of these things, especially in the analog realm, like a lot of time ends up going into trying to get rid of these offsets so that you get more range out of your resonance or feedback. So having a way to invert, having a way to filter out the low frequencies, high pass it in some way. I think that's probably it. Thank you guys for coming and listening to me.